Okay, so for anybody, this is the 27th. I'm going to go through the homework assignment number 3 for anybody that hasn't turned it in up to now. If you turn it in, I'm going to take points off for it being late and for having the opportunity to go through this in class. So all of you who turned it in, something in now, that's fine. As long as I can see that it's in the system. So everybody knows that. And I had a question about the YouTubes. I'm updating that YouTube link every week. So that is under the recordings. There's only 2 recordings there because that's all the space that I had, but I'm updating that Excel with the link to the YouTubes so I don't know if has anybody tried that?
No, I haven't tried it.
Okay.
I watched the recording from last week while I was doing the assignment especially for the last question.
Okay,
I
so you
found the
could
link.
get to them. so it worked, right? You were
Yeah,
able to
yeah.
access.
It was updated in the playlist. I just went back to the playlist link.
Okay. Okay, so just for anybody that's online and listening, you can go ahead and do the homework, turn it in late, but you're going to get points off for it. So, I'm not very good at this. Typing. Okay, so let me. Okay, if you're okay with taking the points off, you're not gonna. If you turn it in, that's good, and you probably should do it because there'll be a couple of questions on the exam. So let me share this screen, and this is the homework. Okay, so you can see this, right? Yep. Yes. Yes, no, maybe. All right, good. Okay, so the first one, you got 6 samples of 20 each, and there were the observations. So the sample means and ranges are shown below. So here's the mean for each sample. So this one sample of 20 pieces, they measured whatever they were measuring, and the mean of those, it was 3.06. The second sample, again, another 20 pieces, 3.15, 3.11, 3.13, 3.06, and 3.09. So 6 samples, 20 pieces each. And those are the averages. And then the range, remember the range, we take the highest value minus the lowest value. And the range for sample 1 of those 20 observations, the difference between the highest value and the lowest value was 0.42, 0.45, 0.41, 46, 46, 45. So then what we do is we take the average of these, the 3.06 plus 3.15 plus 3.11, 3.13, 3.06 plus 3.09, and divide that by 6. And the average there is 3.1. Then we add up the ranges, the 0.42, 0.5, 0.41, 0.46, 0.46, 0.45. Add all those up, divide by 6, and the average is 0.45. Everybody okay with that piece of it? All right. So now, using the factors from a table, we're going to determine the upper and lower limits for the mean and the range charts. So we want to round everything off. You don't need 6 decimal points, even though some of these things came up that way. So here's the same data. And then we know what our X bar is. Our X double bar here is going to be 3.1. And our R bar is going to be 0.45 because we just calculated that, right?
Sorry for the late.
Shauna?
For being late. Sorry for being late.
Shauna, are you asking me a question?
No, like I want to say like sorry for being late.
Oh, that's okay.
Thank you.
Yeah. Have you turned in the homework?
Yes.
Okay, good. So I'm going through the homework now, And if you've turned it in, that's fine and I'll grade it. And if you haven't turned it in and you turn it in after I go through it, then I'm just going to take points off. So I'm glad you could make it. It's nice to have you here. And Blake, I see you joined too. So that's great. Okay. So everybody say we got the X double bar and the R bar. So we have those, and we're going to, so our sample size n equals 20 from what we had up here. A2 is 0.18, so I'm giving you that value. D3 is 0.41 and D4 is 1.59. So we take these formulas and we use them to calculate the upper and the lower control limits. So for the mean chart, for the X chart, the mean chart, average chart, we're going to take X double bar and we're going to add that to A2 times the R bar. And so that's the formula, and I'll give you that formula on the test. And in this case, like I gave you the A2 value, D3 and D4. So I could give you a table and say, look it up, but it's just easier to give you those values. And those values come from that chart that is in that one handout that I posted that is there. And if you were doing this as a lengthier class, then we would show you, I would go into more detail about how that is derived, but that chart for reference is there for any kind of statistics class that you would take. Those things have been calculated, and they're in these tables for a reason, and so we refer to those tables. So what we're going to do here is we're going to take our X double bar, which is the 3.1. Then we're going to add to that the sum of A2, which is this 0.18, times our R bar, which is 0.45. So 3.1 plus the 0.18 times 0.45, that's 3.1 plus 0.081, and that gives us 3.181. And then the lower control limit, we take the same numbers, we just subtract the R bar number from the X double bar. So 3.1 minus the 0.18 times 0.450, and that ends up being 3.1 minus 0.081, which is 3.019. So it's just a matter of knowing the formula, and the formula is given. Okay. And then for the range chart, we use the D3 and the D4. So for the upper control limit, we take the R bar, which is the 0.45, and we multiply it times D4, which is the higher of the numbers. So if you got confused about this, we're going to take for the upper control limit, we're going to take the bigger number. For the lower control limit, we're going to take the smaller number. So we take the 1.59, which is the D4, which is given, times the times the R bar, which is 0.45, and we get 0.716. And then we take the D3 number, excuse me, 0.41, multiply times the 0.450, and we get 0.185. Okay, everybody follow that? Anybody not follow that, since you guys are not giving me any responses here? Okay. You
Okay.
don't follow it, Peter?
No, I do follow it.
Okay. Okay. So you responded when I said anybody not following.
Can you scroll up just one more time, just for a sec? Thank you. Thanks. That's good.
Okay. So that was the first question. Number 2 says we've got a sample of 5 observations that we've been taken. So in this case, we took a sample of 5, and we're going to give you each of these 5. So up here, I've already done that. I've said we have a sample of 20 pieces, and I've already taken the X bar from there, which is of the 20, the average was 3.06 and the range was 0.42. Now in question 2, I'm giving you each individual reading of the samples. Does that make sense? So here's our 5 samples in sample 1, 1, 2, 3, 4, 5. So we got 5 values for the first sample. So we're going to say, and what I gave you was these 6 samples, 5 readings each. And here's the numbers. So sample 1 was 79.2, 78.8, 80, 78.4, and 81. So what I ask you to do is to first calculate the X bar for each sample. So the X bar for each sample is just the average of these 5 numbers. So we take these numbers and get an average. Number 2, we do that. Number 3, number 4, number 5, and number 6. So these in this row, and I think some of you picked the one that had this mean and range written twice, and that was just a typo. But in this case, you take, so this is our X bar now, the 79.48, 80.14, and whatever. Now we're going to take the range. So this is a more manual operation, as I said. So you got to take the highest value here, which in this case is going to be 81, right? And then the lowest value is going to be 78.4. So we take 81 minus 78.4 and we get 2.6. The range in sample 2 is going to be 2.3. I think it's going to be 80.5 minus 78.7. Maybe that's not right. 81 minus 78.7, 2.3, and so forth. So you can, the math, you just have to pick the highest and the lowest. So if you misread that, you'll get the wrong range number. So that's been done at each of these 6 samples. I'm not going to go through them in each because it's just math. And I think you guys can do that. So then what I ask you to do is determine the upper and the lower control limits for the mean and the range charts. So again, round these up. So here's the statistics table with for n equals 5, A2 is going to be 0.58 and D3 is going to be 0. Again, it's the lower one, goes with the lower control limit. And D4 is going to be 2.11, which is going to go with the upper control limit. So for the mean chart, we're going to use the same formula, X double bar plus A2 times the R bar, the average of the R's, and then the X double bar minus that. So what we calculated up here was the X bar and the R bar, but now we got to have the X double bar, right? So we need to take the average of the 79.48 plus 80.14 plus 80.14 plus 79.6 plus 80 plus that. So then our X double bar is going to end up being 79.6. So we've taken averages this way horizontally. Now we're going to take an average of this row only, the means. So these are the X bars. Now we're going to calculate the X double bar, which is the average of the averages. So the X double bar is going to be 79.96. So we use that number. Our A2 is 0.58, and we're going to multiply that times our R bar, which again, we take as these are the ranges. We take the average of the 2.6 plus 2.3 plus 1.2 plus 1.7 plus 2 plus 1.4. That average is going to be 1.867. So we take the 0.58, the A2 given factor times the 1.867. We add that to the X double bar to get the upper control limit. We subtract it from the X double bar to get the lower control limit. So we end up with 81.04 and 78.87. Then for the range, we take the R bar, which again was the average of the 2.6 to the 1.4, which was the 1.867. So D4 is going to be the upper control limit. 2.11 times 1.867 is 3.93 or 3.94. And then D3 is going to be 0. So whatever that value is 0, because we can't have a negative number. So the D3 is just going to be a negative, is going to be 0. Okay. So once you get the numbers, it's just a matter of plugging and playing. So I didn't, in this answer sheet, I didn't put those out specifically, but you have to calculate the X double bar and the R bar in order to calculate this correctly. Number 3 was pretty easy. We had samples of 200 credit card statements that were taken, and the number with errors were recorded. So we did that 4 times, so a total of 800 credit cards. So in sample 1, we had 9 with errors. In sample 2, we had 4 with errors. Sample 3, we had 2, and sample 4, we had 5. Now that's given. And what I asked you to do here was to determine the fraction or the proportion defective for each sample. So all you do is you take the 9 and you divide by 200 and you get 0.45. So the fraction is 0.045 or it's 4.5%. In this case, it's 2% or 0.02, 1%, 0.01, and again, another 0.02, 2.5%. So each of these numbers, all you need to do is divide that by 200. Make sense? Okay, good. I like positive feedback, you guys. Okay, so this is another P chart. So again, samples of 200 were taken, and we looked at how many errors we found, how many defects we found in each sample of 200. And we have 13 samples. So that's a lot. So we've been collecting data for a while on this one, obviously. So on the sample, here's what we got. And so we're going to figure out what our proportion of defects is. So we're going to take the defects that we found that you're given, the 1 divided by 200 for each of these. So 1 divided by 200 is 0.005, 0.5%, 1%, 1% down. So divide the defects by the number of number in the sample. And then we're going to add up all the defects. We found out there's a total of 25 defects. So if we added 1 plus 2 plus 2 plus none plus 2 plus 1, 2, 0, 2, 7, 3, 2, and 1, it's 25. So now we're going to look at the P chart. So, and the P chart is the percentage or the proportion, again, that we're looking at. So, and this is where this is attribute data. So the X bar and the R are variable data numbers, and the P and the C chart, which I didn't give you an assignment for C, are attribute data. So the attribute are things that we count more than we measure. And we're looking for these kinds of things. So we have a total of 25 defects. So to get the P bar, we're going to take the total number of defects, which is 25 out of all of this, and divide by the total number of observations. So the total number of observations we took is 13 because we had 13 samples, but each one of those had 200 units in it. So our total number was 13 times 200, 2,600. So you take the 25, divide by the 2,600, and you get 0.0096. So that was our percent defective, which is actually pretty good. If you look at that, out of 2,600, we had less than 1% defect. And so you got to say, hey, we're doing something right if we're rejecting or identifying less than 1%, because 1% would be 0.01, right? So 1%, less than 1% of defects means we've got pretty good processes here. So then to calculate the control limits, we need the P bar, which we just figured what that is. It's the 0.0096. And we wanted this for two standard deviations, 2 sigma control limits. So we take the 2, and then we take the square root of the P minus 1 or P times 1 minus P, and divide by the number in the sample. So our P bar was the 0.0096. So we take 0.0096, multiply that times 1 minus 0.0096, multiply that, and then divide that by, in this case, the N is 200 because that's per sample. So then we take that number and take the square root of it, and then we multiply times 2, and that number comes out to be oh, and then we add it again back to the P bar. So the 0.0096 plus the number of this whole equation comes to be 0.0138. So 2 times, I don't remember what the math is for that. I didn't write it down in this answer sheet, but 0.0096 times 1.1 minus 0.0096 and divide that by 200 and then take the square root. So that comes out to be 0.0096 plus and minus the 0.0138. If you add that together, the upper control limit is going to be 0.0234. And the lower control limit, because we can't minus that, if it's going to be a negative number, then it defaults to 0. Okay. So you'll see a couple of these on the exam. So you should just, and I'll give you the formula so you don't have to memorize all of the formulas. You just have to remember how to do the calculations. So any questions on that? Does that help, Peter? Okay. Anybody else have any questions? Anybody else get stuck?
I have a question, not to the spec, but just
Go ahead, Aggie.
For the test. Because I use formulas in Excel, do you want us to show you how we came up with the solution, or just the solution is the important one?
I usually have multiple choice questions because they're the easiest. So, but I might have a couple of fill in the blanks. You don't have to show all the work. If you do, then I can kind of see where you, if you made an error, where you made the error. So, because like in any of these, if you make a mistake with the P bar or the X double bar or the R bar, then it's going to mess up your whole thing.
Right.
So yeah, if you can show me a little more, and on the exam, I'll give you a place to write that in, because reason I like multiple choice, I'll be honest, is one, you get the answers very quickly after you take the test. And two, I don't have to spend a lot of time grading because I have other things to grade usually at that point. But I will give you those because there's not that many in this class. It won't take me that long to grade them. So I will give you a couple of those so that you can show your work on that. But there won't be like 10 of them. So it won't take terribly long to do. Okay. Okay. So I'm going to stop sharing. Okay, good, Marcus. I'm glad I cleared up any questions you had. So yeah, you'll be able to look at this and go through this again in preparation for the exam. Oh, and I did post a study guide on the exam. So that's in Canvas now too. Okay. All right. So we're going to flip back to the book now. So let me get just set up here. So we did chapter 7 last week. We're going to do chapter 8 tonight. Then I skipped a whole section of the book on some of the leadership aspects of this. There 9, 10, 11, and 12. I think those are the ones I skipped. It's not that I don't think that those are valuable, but because this is a limited kind of class time period, I wanted to make sure that we got through some of the other things. So I skipped those chapters and went, and we're going to do chapter 8 tonight. And then we're going to jump to, I don't remember what it is, 15 or something like that. Yeah, 15. So we skipped from 9 to 15, those 6 chapters in there. But I guess I better share this, huh? Okay. So chapter 8 is about operational excellence. So we've talked about a lot of the lean concepts and the basics of lean, talking about getting rid of the waste, getting into continuous improvement and trying to get better and better. And then we talked about some of the statistics where we create control limits for ourselves. We create the control limits based on the actual data that we collect. So we have a reference there. And then we track our process to see if we stay within those limits. So it's not a case where you calculate whether you take the first 5 samples or the first 13, as we did in the one example or whatever. And then you calculate your control limits, and then you continue monitoring your process and charting and looking to see that your values are within your control limits. So again, we want to be within the spec limits, which need to be outside of the control limits. Once we verified that we have a process that has control limits inside the spec limits, then we're just checking to make sure that we stay within the control limits. Or if we find a point that goes out, that we can find a cause, an assignable cause that says this is why we had an error here. So the process is still good. We had some kind of external force that caused that abnormal or anomalous reading to be there. So then we don't say, okay, we're out of control for that. Now, if we start seeing lots of data points outside of the control limits, then we have to say we probably lost control and figure out what's going on. So you don't want to calculate those control limits, say, this month, and then let them go for a whole year. But you don't have to keep recalculating the control limits every week or every month. You might want to do some calculations maybe every quarter or every 6 months to make sure that you haven't changed a lot of things. Or if you make a significant change to your process, then you'll want to rerun some samples and recalculate your control limits, just to make sure that you've that you're assessing and you're viewing your values within everything, the latest process that you're using. So when we talked about the SciPoc and the flow chart and all of those things, if you make any significant change to that, then you do need to go in and recalculate your control limits and make sure that you're accounting for every change that's in there. If you make some slight changes, then it's kind of a matter of your call. Do you want to go in and recalculate those just to make sure you're still on track? Or are you confident that whatever tweak you made didn't really change the process and you're not going to affect the output or your level of control that you have? So it's kind of a gut feel. It's never a bad thing to recalculate that, but you don't have to recalculate those control limits, like I say, frequently. If your process is in control and if you have good indicators that your process is in control and you're checking your parts and you're checking your measurements consistently to make sure that you're still following in that same range, then you know that you have the variability that's in control and you're not exceeding those control limits. Then your process is, you can count on that process as being a good process. So for operational excellence, which is what we're striving for, when you get processes that are in control, that's a part of what you're trying to do for operational excellence. So the when we talked about the implementation and the control, that when we have that in the DMAIC model, then when we get to that control stage and we have this recurring control that's giving us good readings, then we know, hey, you know, we're doing the right things and we're in the right place. So we're going to look at these. So we've got a leadership tie-in here where we're looking at this philosophy of continuous improvement. So I told you Lean and Six Sigma are multiple things to companies. They are initiatives that companies undertake in order to see, to improve. They are activities that you do to lean things out. You can perform Kaizens. You can do an active lean exercise where you go in and identify the waste. Part of leaning is value stream mapping and flow charting and looking for that, doing SciPoc diagrams so that you really know who your customers are, what your inputs are, all those other things. All of those are lean tools that you're applying. And they're also a whole philosophy based on that Toyota production system that says this is how we continue to get better, how we have this continuous improvement. So they're actions, they're tools, they're a philosophy, they're a mindset. And it's part of a culture that gets developed when companies really embrace this. So we know that in order to do that, consistency is really, really important. We can't be in control. We can't have continuous improvement if we don't have some consistency and can't rely on some of the things that we're doing and know that we've got things that are repeatable and reproducible. So we've got to have that. We've got to have a workforce that is trained and that is empowered, meaning they are encouraged to speak up when they see a problem or see something that isn't right or isn't going in the right direction, that they have the ability. One of the big empowerment things for factories when you have processes that are running a lot of parts is the ability to shut the line down. And when I was in the corporate world and I would go audit these suppliers, they would say, yes, any worker on this production line has the ability to shut it down if they see a problem and they've indicated that there's something going wrong with the process. It doesn't mean they shut it down every time they find one thing that's wrong. But if they find something that is repeating or that they feel is significant, then they have that empowerment, they have that accountability, responsibility to the rest of the team to say, stop, we got a problem, let's go check it out, make sure that it is a problem that I'm seeing. And then if it is, let's fix it before we start the line back up, because we don't want to continue to make bad parts. There's nothing worse than a production line that's making parts at whatever rate that is over and over and over repetitively, and you're just continuing to make bad parts. So you're just pouring money literally down the drain, pouring it into the trash can, where you're going to have to pull all these parts out and put them in the trash or rework them and fix them, whatever you have to do to them. So you want to make good parts. I think I told you my background is as an industrial engineer, and I say we are the laziest people on the planet because we never want to do anything twice. So do it right, do it once, do it right, do it the first time, and then we don't have to do repeats and reworks and fix scrap and all that kind of stuff. So it's worth taking the time to figure out what's the right way to do it before you actually get it done. Now, that can be an analysis paralysis kind of thing, where you continue to analyze and strategize with what's the best way to do it. And so that you actually put off doing anything, which is not a good thing, because you want to keep making product. You've got to keep that product flowing. But empowerment is a big part of that. The standards, the requirement need to be very visible. So we just did some analysis in terms of charting. So I didn't ask you to actually graph these, but you could graph those numbers on a graph. So when I gave you the samples and all of those different values, what typically you would do is you would chart that and actually graph those points, and then you would show the upper limit, the lower limit, the control limits, and then actually have the parts graphed. And that was in some of the examples, and that's a little bit in the book too. So, and then you would display those charts publicly in the factory, where people that are actually working on that can look at those charts on a daily basis. So the charts are updated frequently. They used to be, printed and posted. These days, they're on like iPads and things that are hung there so that the data is real time on different screens that you can see. So you can actually see how you're doing and make sure that you're staying in control. Excuse me. I'm going to try to sneeze here. So we want to be able to see those standards and see how you're doing against those standards. So then we have transparency in all changes. Anytime we make any tiny little tweak, we make sure that that's out in the open, that it's documented, that everybody knows what we're doing, why we're doing it. So then you can monitor the results and see, did it have a change? Sometimes we're tweaking something to try to get it better, to try to narrow down those control limits and get them even tighter, because that shows us our variability is less. And that's what we want, is not much variability against our target. And sometimes we just need to make a change for whatever reason, to update something, change a tool out, like change a drill bit, do maintenance or whatever. But all those changes have to be very transparent and out in the open. And then the whole culture is going to align with the values that we have in empowering people and striving for getting rid of waste and rewarding that kind of behavior. and doing it right the first time, and that whole working together team approach. Because that, again, lean is the philosophy, it's an approach, it's a culture, and there are a lot of tools that go with it that help you be able to do that. It's kind of a mindset as well as anything else. So these are the 7 principles that we use in lean. And I think we've talked a little bit about these before, but they emphasize them here. And it's all about focusing on the customer. And I always work in operations, and I teach operations management in the CSUN system, or in the CSU system. I teach at both CSUN and Long Beach. I teach usually a class every 1 or 2 classes a semester I teach. And so, but I tell them, this isn't a marketing class, we're talking about operations here. And, but that doesn't mean that we don't focus on the customer. So in operations, we don't have much customer contact. We're producing the things, we're in the manufacturing or generating that or doing the work. And so it's important that we do that, but we have to know who the customer is and what the customer is wanting, which is going to be translated to operations through the design that we have that has the specifications we're trying to meet, and through the marketing team giving us the requirements that they have and the level of quality that they help us establish that is the customer's desired level. So we are focusing on the customer, even though we aren't interfacing with the customer. We aren't doing any sales, we aren't doing any pricing, we aren't doing any of that, but we are producing these things. And as part of the Lean Six Sigma, we want to keep that customer use and that customer needs and wants in mind as we produce everything. So we want to understand how the work is performed at each area along that supply chain, each area along the stages. What is supposed to be happening? Is that happening or not? Even if that is like, again, making sure the forms are filled out correctly, making sure that they get dated and stamped and filed and copies made to whoever and submitted to the right organization and all of those things. So how the work is performed, what is the right process, what are the right steps, managing that workflow so that you can get as much done as is reasonable to do within a certain amount of time, whether it's a day, an hour, a week, or whatever, trying to take out the steps that are not value added, that turn out to be waste, and that's doing things over and over again, or making room for too many errors so that you have to either erase or rip up and start over. Looking at all things that are data and fact-based. So as part of Lean and Six Sigma, we really rely on facts and measurements and standards, visual things as much as possible. For some of the things, it's harder. So for variable data, that's pretty easy. We're measuring things, we're calculating things, we're taking calipers and measuring, or taking even a laser and measuring, or maybe just a ruler and measuring. So we actually have things to measure or scale, maybe if we're measuring weight. But we're still looking for data and fact-based. So even if we're counting things like scratches or paint drips, we're still trying to assess those in terms of how can we define that, or turn that like a survey where we take soft data and we have people fill out surveys and we turn that into things that we can measure. So on a scale of 1 to 5, is this a 1 or a 5? You guys have all taken these surveys probably 100 or thousands of times in your life. And the survey itself is very subjective, because the survey doesn't say, go measure this and tell me what that number is. It says, how do you feel about this? Or how was your experience, right? I was on the phone with somebody, I can't remember what it was, not too long ago, and it was, how did you feel about that transaction? I think it was, I put stuff in to a doctor. I was going to some doctor. My husband and I've been going through the end of year checkups, right? You go to this doctor and that doctor, and you go to the doctor and then they tell you, well, now you got to go get some blood drawn. So they do all these tests. And so you get this thing that says, how was your experience when you went in to have them draw blood to tell you that you're healthy? So, all of these things. So you can be very cynical about it and say, well, I didn't want to be here in the first place. I think this is a bunch of junk and I'm tired of being, having to go to the doctor every year and get blood drawn. And they hurt me when they took the blood, they couldn't get it out. So if you're like me and you have veins that are hard to hit, and sometimes it takes them 2 or 3 times to stick me, and by that time I'm just ticked off, right? So you could take those surveys and you say, tell me how you feel about this, whether it's 1 question, 5 questions. Some of those things are so long, it's like ridiculous, 20, 30 questions. And all of that is, how do you feel? What do you think? What's your assessment? All of that is subjective. But when you put down that it's a 4 out of 5, then it becomes something that you can measure, becomes quantifiable. So we take these things that are qualitative and we turn them into quantitative by saying, give me a number from 1 to 5 or 1 to 10, and then I will add up how many 1s, 2s, 3s, 4s, 5s we have. And then we can actually get some numbers to work with. So we're trying to get data, if we can, somehow to manage that, and facts as much as possible that are verifiable. And when we think about that, measurements are pretty much factual. You don't measure it 2 or 3 different ways. If you measure it the same way in the same context of heat and humidity and all those things, you're going to get the same answer. So how can we get things that are fact-based and data-based and take as much subjectivity as possible out of it? And in order to do that, you need people that are trained, that are knowledgeable, that are, we use the term SME, subject matter expert, a lot in Lean and Six Sigma. So when you take, we're not just taking people, oh yeah, here's the factory floor, we got 100 people working out here, so we'll pick these 5 and we'll bring them in and ask them this. No, we're going to take the people that work on this station, that know this job. They are the experts at doing this because they've done this job for some period of time. So they are therefore the subject matter expert at that. And we want that expertise as well as other expertise. Maybe you want an outsider's view of that. So you bring them in, but they're not necessarily a subject matter expert on this particular station. So, and even sometimes the designer is not the most knowledgeable person because they dreamed it up that it should look like this and it should work like this, and they've done it once, but the real experts are the people that make it happen day after day after day. And then we want systematic improvement, which means, again, we're not trying to get huge stair-step improvement functions. If we can, that's great, but we want continuous improvement. And we want to know what we're doing that's driving those improvements so that we can keep doing that and keep moving that in the right direction. So systematic through the system, through the process that's documented and that we have there. So again, the customer focus, we're looking at the lean mindset. We're looking at it from an external perspective, not an internal perspective. So you can say, we've got the best product on the planet if you work there and you're looking at that. But if you're not a buyer of that and you're not assessing that in terms of whatever else is out there, then you can have a problem. And companies do this more often than you think. Do you guys all remember BlackBerry? How many of you had a BlackBerry? I know I did. No? You always were better than that, huh? But the BlackBerries were pretty popular and they were very common for a while, and people, you used your thumb to type all this stuff on the keyboard, and there were people that loved that and really wanted to continue doing that. And what happened to BlackBerry?
Well, it was discontinued.
Discontinued. Why? Do you know?
There's more user-friendly and updated alternatives. They're better for people.
Right. The alternatives were more appealing to a broader audience, right?
Mhm.
More people liked simpler solutions. And I don't know if you know this or not, but there was actually a company that was developing a BlackBerry-like keyboard that you could attach to your iPhone and use that. Did anybody see that? Anybody know about that?
I think I remember hearing about that.
Apple shut that down pretty fast and said, nope, you're not doing that. That's not the purpose of the whole thing, and that's not in line with what we want, and you're violating our patents and some other things. And I think they took them to court, and or they were going to take them to court, and that got shut down because they said that is not the way this product is intended to be used, and you can't do that. But the BlackBerry is not around anymore because it got, just like Alexander said, it got supplanted in the marketplace. So you could be very good at looking at internal BlackBerry when you were making it. Oh yeah, this thing is great. It does all these good things, and we can do this, and we can make this better, and all of this kind of stuff. But if you weren't looking at it from the external perspective and saying, these guys over here have a much better idea. It's more fluid. It's easier to use. It's a bigger screen. It's, all of these things that are going to make, and it's easier to use than something trying to type with this kind of thing. And I remember the flip phones too, that people could type on, where you had to hit it like once for the number, 2 for the small letter, and 3 for the capital letter, or something like that. It was crazy, wasn't it? But we thought that was high tech, and it was at the time. But you've got to keep that external perspective to say, not only what are we doing that's so great, because we're such a great company, we can beat on our chest and tell us how wonderful we are. But if you're not looking at it from the external perspective as the customer and saying, what is going to really work for me, and what is going to make my life easier and satisfy my needs and wants, then you're not going to be able to achieve what you want to achieve as a company. And so you have to keep that perspective while you look at improving your internal processes. So you're trying to balance your internal needs with your external focus, and your stakeholders, which are both internal and external. You're going to try to balance all of those needs, and then also try to satisfy as many wants as you can, because that's really where the rubber hits the road, and where companies make money is when they can give consumers not only what they need, but what they want in addition to that. Whether that is an extra feature, an extra color, a softer version, a more reliable, tougher version. The first iPhones didn't have cases and all kinds of nice things to help protect it, right? But quickly thereafter, you started seeing a lot of different cases for that. And you had those screen savers. So you could put that piece of plastic on top, remember? That was a big thing to buy, so that you could put that on top of your phone and protect the glass. I don't think a lot of us realize just how tough that glass is. And then yet the kids next door have managed to break theirs a couple of times. So that glass is pretty tough, but it doesn't survive all the treacherous things you can do with it. So, what are the needs and the wants of the people? And now there's a whole cottage industry around, lots of cottage industries around what you can do in terms of put stickers on your phone, get different cases. There's the OtterBox, and then there's the very soft, cheap things, and the very expensive things, whatever people desire for that kind of thing. So what are the expectations of your customers, and then how are you satisfying those? But then you've got to keep this air of reasonability in there too. You can't go overboard too much, because if you try to give every customer everything they want, then you probably will fail as a business, because you're not really focusing on the few things that you need to do to be successful. But you do want to instill some creativity and innovation. And lean, you think that in some ways you think about lean as being traditional and very regimented, and processes, and you follow the process and you don't deviate, and all of these things. So in that way, you think it might be very slow and pedantic, but it's actually very creative and brings in a lot of innovation, because you're encouraging people all the time to think of ways to do things better and make their life easier, making this product, working in this office, working in this environment. How can we do things better? And when you embrace those ideas and look for how you can implement those changes, not just willy-nilly say, oh yeah, let's go try that, see how that works. So you need a deliberate kind of process to implement the changes so that you know that you're not messing up something else down the road. But when you do that and you have everybody understanding that, then they quickly come up with ways to continue to make things better through creativity and innovation. And they're more open to different ideas and doing things in different ways. So it's an important factor, the customer focus. So how work is accomplished, they have this term Gemba walks. And Gemba itself means just this walking around. And everywhere I've worked in a manufacturing area, the best managers go out and take a walk on the factory floor and see what's going on. So go see yourself. I worked in areas where I wasn't on the floor very often, but I went out often enough so that I knew people that were working out there. I knew what was being done where. And I always encouraged the buyers and the planners and the people that worked for me, go talk to those guys, go look and see how that's made. You'll understand it better when you go see that part in the production line and those things happening, or see what those numbers mean on when you're looking at the spreadsheet and that looks good and you can do all these wonderful things with the spreadsheet, but do you really know what that means in terms of the factory and making that happen and stuff like that? So it's important to do that. The Gemba walks are an important part of that. Process stapling means just making sure that the processes flow together. So it might not be like the manufacturing and the packaging. You want to make sure that those processes have a link and go together pretty well. So you don't have to do them run right after the other, but you have to make sure that they support each other and that you're not doing something in manufacturing that's going to mess up your packaging, that's going to mess up your shipping or anything like that. So making sure that you're looking from end to end on everything. Looking at how you manage changes in your processes, how you can find different tools and equipment and create some of those things that you need to actually help people in the manufacturing area or in the production area. Even if you're producing paperwork, if you're producing, if you're making cookies or you're making any kind of whatever your product is or the service that you offer. If you're in a salon, handling customers, what are the things that you can do to help make that flow smoother and work better for everybody? So you're providing tools and equipment, methodologies, and working together on that. You're training people so that they know what to do. You're training people to work together so that they support each other. Keep in mind that simple is superior to complex. So I know I've worked with a lot of engineers, and some of these engineers think that the more complex it is, the more beautiful it is. And really, you have to show them that no, simpler is better. If I can teach somebody to do this job in an hour, it's much better than if it takes them 3 weeks to learn this process. So let's make it as simple as we can. Then we have more flexibility. We can ramp it faster. We can get more people trained on it so that we can move people around in the factory as we need to. It's all good. And in the office, it's the same thing. The more you can train people to do different parts of the job. Say, is somebody in here like in accounts payable, or is that in another class that I have? In the finance department, like in accounts payable? No, I guess not. But if you think about it, if you're in the accounting area, the finance area, so there's accounts payable, there's accounts receivable, there's just the general ledger where you're just collecting data and doing the month out close and all of that. The more you know about that business, the more valuable you are. Once you know something about accounts receivable, you could probably do a better job with accounts payable in that way. So if you're trying to get the money from the customers, that's going to give you insights that you could use to apply if you have to go work in the accounts payable, then, working with your customers who are trying to get paid on time or early or whatever. So you can look at both sides of that coin and figure out how you can do those things in a faster manner, more streamlined, less errors in all of that. So all of that is good. So the more that you can train and look at it from other perspectives, the better off you're going to be and the better off your employees are going to be. So the simpler is better. Visual tools are good methods. It's much easier to have a Kanban card and flash that than to try to track somebody down and say, hey, what I need is this, this, and this. If you have a card that has the right SKU number on it, the part number that says this is what I need and this is how many is in my lot size, then it's much easier for somebody to get that for you and to have that come to your station than if you're trying to translate all that information on a regular basis. And then go back to the 5 S's. Those are very important. So then manage the workflow. We want to be able to, did I skip one? No. Manage the workflow. We're looking at bottlenecks. Bottlenecks are an uneven, unbalanced line. We want to remove any constraints, get this nice smooth flow of materials and people working to supply the goods and services for our customers. That's what we're trying to do. The high runners are the Pareto principle. Have we talked about the Pareto principle in here? I don't think we have. Does anybody know the Pareto principle?
Is this the one where 80% of your success is by 20% of your people?
So 80%, that's exactly right, Alexander. 80% of the results or the outcome of something is usually driven, or the effects of something are usually driven by 20% of the causes or the drivers. So, and it works in a lot of different ways. It works that if you're in a company, 80% of your revenue will probably come from 20% of your customers. So you won't have, if you look at who are my key customers, you'll have a small number that are driving most of the sales. 80% of my defects come from the same part, from the same supplier, from the same product, any of those kinds of things. And these things happen they happen naturally. So this was a Pareto principle that was, I don't know what the right word is, discovered by someone in Italy, and quite a while ago. But it's that 80, we call it the 80-20 rule, right? That 80% of the results come from 20% of 80% of the effects come from 20% of the causes. So it works in, kind of plus things like generating revenue, and it also works with generating defects. Where do your defects come? Most of my defects in my factory are maybe this type, or come from this supplier, or come from this part that's the toughest one we have, or whatever. So if you do the data and you do that, and you can come up with a Pareto chart. Anybody know what a Pareto chart looks like?
I've definitely seen them, but I don't remember off the top of my head.
Y'all know what a bar chart is?
Yeah.
So a lot of times when we have a bar chart, it's in the shape of a normal curve, right? With the biggest bar in the middle and then on either side. So it resembles the normal curve. You know what I mean when I say normal curve, right? So Pareto is where the biggest bar is the farthest to the left when you look at the chart. So it goes down. So this is our biggest one, and then the next biggest, next biggest, next biggest. So it's from most to least of revenue, of defects, or whatever. So we want to look at those, and the reason it's really important that we do that in business, whether we're looking at who are our key suppliers, where's my money going, who are our key customers that are giving us the money, where's the majority of our income coming from, is because you want to prioritize those that are big and keep those in place And then you want to try to see how you can drive some of the smaller ones into bigger numbers, right? If you have a customer that's in the middle of that Pareto chart, you say, okay, how do I move them from in the middle of this to, again, one of these bigger bars? How do I increase that? So if you're looking at revenue, if you're looking at number 10 or 11 or 20 on your list, you're going to say, they got this much revenue. So even if I could get them to double it, is it going to be very effective? Am I going to feel that very much? The answer is probably no. But then if I take somebody who's in the middle and I can increase them by 50%, then I'm probably going to get them to a bigger step function. So I want to put my resources into that. It's the same way with defects. We want to say, what's our biggest defect, or what's our costliest defect? So you can look at it in terms of what costs the most in dollars, what costs the most in time, what is the highest recurrence of that. So how many is the most? However you can define it, then you look at what is the biggest. And if I'm working on improving, then I want to go reduce that one first. Again, if I can take one of these tiny little ones at the end and wipe it off, that's not a bad thing. But how much investment do I want to make in that versus putting those same resources on that one that's the big honking bar that's really costing me the money? So if you look at that and say, hey, I can reduce that by half, that's a really good thing. Then I'm going to start to feel that in my business. I'm going to say, you know, I'm going to get better results on this. I'm going to get more profit, reduce my cost or whatever, or all of the above, versus trying to take a little one and erase it. Now, I always say the books will tell you don't look at those. And I always say, look at the top, you know, whatever. And if you can fix it quickly and for very little investment, then do it by all means. If you know what's wrong and you can fix that and erase one of those things, then there's no reason not to. But if it's not something that's really, as they say, quick and dirty, then what you want to do is to make sure that you spend your resources on the ones that are going to give you the highest payback on the investment that you're making. If you want to go tell your people to work on something, you want them to work on something that's your biggest pain point, then you know, versus picking and choosing little things to do. So that 80-20 rule, that Pareto principle comes in handy. And then, you know, you don't really want to spend a lot of time on the bespoke, the unique things. Those things happen, but that's not, if they're not recurring and they're not, you know, really significant, then it says go put your time and energy and your resources into the things that you're going to get the biggest return on. We want the waste out of there. So they talk about WOMBAT in the book, and they talk about money, brains, and time. So MOBA, I guess, and then T, time. So those are the three WOMBAT waste. So are we, you know, what, because companies tend to think more one-dimensionally, like we're always looking for money. Okay, money, 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 right? But money comes in lots of different forms, and it can be, you know, a waste of scrap, or it can be the amount of rework that you have to put in, or overtime, or, you know, poor forecasts, or any of these things. So what kind of money are we looking at there? And then brains, if we're not letting our people use their brains, you know, there's the thing they tell you that I've read is kind of bunk, but they tell you we only use 10% of our brains. And I know sometimes there are jobs where people think they're only using about 2% of their brains. So get people engaged to think about ways to do things better, because the people that are doing that actually have the insight and can say, hey, this would be better if I had this tool, if I could do this, if I did this first and then this last, then that would make this go together better and quicker and whatever. So don't waste people's brains, and for Pete's sakes, don't waste time. Time is one of the biggest things that gets wasted, and yet it's hard to measure. It's often hard to see in a workplace. Okay, where is the time being wasted? And I'm not talking about just people going for coffee, you know, and taking 15 minutes to go get a cup of coffee every hour on the hour. but they are looking at things that take too much time. How can I reduce the time it takes to complete that step? How can I streamline that? How can I remove redundancies in something and make it simpler and easier so that it goes faster? Not just in a factory, but in any kind of an area where we can do things and maybe do things in series, or maybe take things we do in series and figure out how to do some things in parallel and not have such a waste of time. So think about money, think about brains and brain power, and think about time. And then Tim Woods, we talked about before, these are the wastes, right? The time, the inventory, the motion, the waiting, the over processing, overproduction, defects, and skills. So these are the it's 8, 1, 2, 3, 4, 5, 6, 7. Yeah, this has the 8 in it. So sometimes it's 7, but that's the skills at the bottom that gets added on. That is also part of that 8 wastes. So again, fact-based, data-driven, that's what we want to do. Data is not information. This is something that so many companies, we have more data today than has ever existed in the history of the world. Mankind today has more data because there's more stuff being collected on anything and everything all over the globe. And you know what? It's data. It doesn't mean things. It doesn't have significant meaning until you actually put it into a framework or analyze it or figure out what it's telling you. If it's telling you a story, then that's a good thing, and that will help you run your business. I've seen a lot of businesses that have data. Oh yeah, we did this, we did this, we did this. And I said, okay, so how are you doing? Well, we're really not sure. Or we think this. Okay, if you have that much data, you should have some kind of indicator there. It should give you information that either tells you that you're on track or you're off track, or what direction you should go in, or should you do more, should you do less, whatever. So you have to interpret that data and analyze it and make it mean something. So data is not the same as information. Another thing is assumptions. And this, I think the book says never assume, but I also say document those assumptions. So if you do make these assumptions when you're doing, when you're documenting how to make your peanut butter and jelly sandwich, what are your assumptions? The first thing is that somebody's going to want to eat the bloody thing, right? You're not going to make a peanut butter and jelly sandwich without somebody to eat it. Now that sounds kind of silly, but sometimes you need to document things that are obvious at the time, because that's why we're doing it. We're hungry, right? So we want a peanut butter and jelly sandwich. If you wanted a ham sandwich or you wanted a bowl of soup, you wouldn't be making the peanut butter and jelly sandwich. So you have to assume things. And then what else do you assume? You assume that, oh, I do have a knife that I can spread this with. And I assume I have the peanut butter in the pantry so I can go pull it out on, it's on the shelf, so I can go pull it out and put it on the bread. So whatever you're assuming, try not to make assumptions, but if you do make assumptions, and sometimes we need to, then you need to document those and just keep those around so that you know that. I work with companies who forecast and who do different things. And I always say, okay, what kinds of things are leading you to make this assumption? You're assuming that Christmas has been your biggest time, your biggest sales. The months between October and December have been your biggest sales for the last 10 years. So you're assuming that there's nothing that's going to impede that or keep that from happening, right? I mean, think about the pandemic. When back in March of 2020, which it's hard for me to think that that's almost 4 years ago, but it is. It's 3.5 years ago. Then what were people thinking that they didn't, we didn't know what we didn't know. So the assumptions that you make are important to say, we assume that pattern is going to stay. Now, you don't have to, I'm exaggerating a little bit here. You don't have to say, well, we assume that people are going to keep spending money at Christmas. They have since we've been in business, and that's been our biggest quarter. So we can assume that. But you do want to assume, okay, what does that mean? That there's probably no major recessions, that there's probably no physical impact to like a war going on. If you were getting sunflower oil from the Ukraine, and all of a sudden now you can't get that or in the quantities that you needed before because Russia has invaded Ukraine, and we've got stuff going on there that's impeding those people from growing the sunflowers and processing the oil. So you do have to make some basic assumptions. So document those, at least make sure that everybody's in sync, and then don't assume that everything is going to be like it always was. Trust but verify. Again, go back to data, measure, check. So yeah, our process looks like it's in control. That's good. We got good control limits. They're well inside our spec limits. We don't have to do this anymore. So we don't have to inspect or we don't have to do anything. Not exactly. So trust that they got my process done, but I'm going to verify it because I'm going to keep checking every so often to make sure that my results are where I want them to be. Reduce the variation. Get the clear correlation between what you're doing and the results you want. Because sometimes you make changes and you say, oh, this is going to make our output better. And you do the changes and then you look at the output and there's no change. So make sure that you check for that correlation, because not everything manifests the way you think it's going to. Get, again, these subject matter experts involved. So, you know, they talk about a black and white hat, so good and bad, and not necessarily that way, but make sure that you understand the good and the bad and that you can identify those. And then look at your sources of data and how reliable those are. And are they repeatable? So in statistics and in quality, we talk about like a gauge R&R study, and that has to do with repeatable and reliable. So I'm not going to get into a lot of that there now because it's pretty in-depth, and there's some studies that you can do that are all statistical based. But what you really want to think about is this reliable? Can I repeat this? So if I take data today and I take it tomorrow, am I going to use the same process? And it's not that I'm going to get the same result exactly, but if I'm not doing it the same way, then I can't expect to get the same result. And is there something that I need to do to make sure that I'm not putting a lot of extraneous changes or variables into this? So, you know, is the temperature changing? Is this something that is outside that it's going to tell me something different when it's cold and wet or overcast versus a bright sun and no clouds in the sky? So what is my data source and how reliable is it? And then what can I do to do this continuous improvement? And that means using processes like the DMAIC approach so that I have a process that's going to help me make the changes I need to do so I can get those improvements and get them over and over and over. So that's chapter 8. Any questions about that? Okay, why don't we take a break? It's 8:06. Why don't you take 15 minutes, or I'll give you even a little bit longer break, maybe come back at 8:25, which is 18 minutes. Does that sound good to everybody? And then we'll jump into the next chapter so we don't have as much to cover next week.
Sounds good.
Thank you.